What's up? In this tutorial, we are going to cover how to set up runtime PCG foliage spawning in Unreal Engine 5.6 and beyond. We're going to take advantage of some new nodes that are part of the engine now that let us spawn our grass on the GPU, which gets us pretty close to how landscape grass spawning has been done in the past using our landscape materials. So I'm going to be showing you how to set that up with PCG and also how to drive that using our landscape grass output from our landscape material as we would have done with the old landscape grass system. But now we can use PCG and leverage all those new tools. We have a lot to cover, so let's get into it. So the first thing we need to do to enable runtime grass spawning with PCG is, of course, enable the PCG plugin. If you haven't done that already, you can do that by coming to the edit dropdown and choosing plugins. And we're looking for PCG. And we want to enable this first one, procedural content generation framework. Go ahead and enable that and restart the engine if you need to. Next, we're going to go ahead and use a preset that now comes with Unreal Engine 5.6 and beyond that gives us one of the nodes that we need for runtime grass spawning on the GPU. So to do that, we're going to come and right click in the content browser. We're going to come to PCG and choose PCG graph to create a new graph. And now, like I mentioned, 5.6 and beyond, we're going to get a bunch of presets here that we can choose from. And so what we want is to choose this runtime grass GPU option. We're going to click on that and choose initialize from template. And I'll call this PCG runtime grass. And we'll go ahead and drag that into our level. And right away, you can see it's automatically spawning these kind of temporary little grass meshes on our landscape, which is really cool. This is not actually spawning at runtime, it's spawning offline by default. And actually, if you open up the graph, it gives you a little bit of little tips and things we need to do to set this up to generate at runtime. First thing we need to do is come to our graph settings here and make sure we're using use hierarchical generation. Next, in our level, we need to choose the PCG graph here and come over to the right side and scroll down to where it says under the PCG component, the settings and the graph instance, we want to choose is partitioned. That's going to basically generate these PCG points in little partition chunks, which scales better over our world and interacts with the grid spawning system we'll talk about shortly. So we're going to go ahead and choose that and then switch our generation trigger from generate on load, which it just did when we dropped it in, to at runtime. And by default, you're not going to see anything. And that's because it would if we were playing the game. Like, for example, if we come here and hit play, since our camera is basically the character in this case, or if we were using a third-person character, whatever, it would basically spawn around our character. But while we're working on it here in our viewport, or if we're using this for like rendering or some other application, we want to switch our viewport camera to be the generation source for the runtime generation. So we're going to come and click on the PCG world actor here and come over to the runtime generation. And right here, it says treat editor viewport as generation source. As soon as we check that on, you can see that the PCG points are generating near our viewport camera, not just our game camera. So if we move far enough away, we can see it starts to unload. And as we get closer, it loads in. Now we can safely expand this PCG graph to encompass our entire world. If we have an open world landscape, it really doesn't matter because we're only spawning points directly around us. It could be an infinitely sized landscape and this would just work normal. It wouldn't get any slower because of how big the landscape is. So we can come and click on our PCG graph and I'm going to go ahead and expand it to fill my entire landscape. Great. So now the PCG graph, if we take a look at it, is encompassing my whole landscape. And now we can see we can just move around in our viewport here and the grass is loading and unloading pretty well. Okay, so now let's talk about how we'd adjust the look of this and how dense it is and, replace some of the meshes, for example, with actual grass here. With the PCG graph in our level, if we come down here to the instance dropdown and we come to the parameter override section, inside the graph, which I'll show you in a minute, we have parameters set up already for us. For example, our density filter, which is gonna allow us to cut down on the density of the points. We have two different noises. We have a random noise and a spatial noise, which is helping us give this kind of organic looking pattern of spawning on the ground. For example, if we wanted to change the size of this noise, we could come over to the spatial noise size, and you can take a look at these little blotchy areas. If we go ahead up that to 500, you can see those blotchy areas get a lot bigger because we're expanding the noise. So these parameters directly affect, or rather override, the parameters that are plugging into our nodes inside the PCG graph, which again we'll look at in a second. But I just want to show you here how to change the look of these points. We're going to come back to these in a minute when we have our actual meshes in there, because it's going to help us define the look. But I'm going to go ahead and double click on my PCG graph to open it. And I'm going to close this HLSL source window for now. We'll come back to that. So this is the general setup of our nodes. We have a get landscape data node, which is plugging into a grid size node, which is how we define how to break up our points into little chunks that can be loaded and unloaded at certain distances. We'll come back to that in a moment. We have our graph parameters, which is basically getting all those parameters on the outside of the graph there that we were just adjusting. Those are built here in the graph parameters window down here in the bottom left corner. Those are all parameters like you might make inside of a blueprint, mostly float parameters in this case. And so it's this node is basically a catch-all that's taking all those parameters and plugging it into the graph parameters input on this node here. Now this node here is kind of the brain for this PCG graph. This is where most of the logic is happening, and it is a GPU point generation node. What that means at this iteration of Unreal Engine is that it's using HLSL code to define a bunch of points, doing a bunch of things to them, like adding noise, filtering them, all that good stuff, and spitting out those points here into the static mesh spawner, which is then spawning meshes at those points location. So this is really the node that's letting this stuff happen on the GPU, which is what is letting it happen so quickly, and which is what we need when we're spawning things at runtime, because we can't really get bogged down by a lot of logic that we're doing on the CPU. This is much faster, just can be really quickly calculated on the GPU directly around us, and that works really well. Okay, so if we go ahead and click on this point generator, we're gonna actually jump into and look at its code in a minute. But first thing I want to point your attention to here is the number of elements. What this is basically how many points are generated on each partitioned or each little grid of our PCG points. So you can see here as we move these little grid areas that are spawning in and out, this is basically telling us how many points are on each of those little grid areas. So if we drop this down to 5,000, for example, we can see we're getting a lot fewer points per grid area. And this is something that will just depend on what kind of foliage you're using, or how efficient you want it to be, whether you can actually handle calculating so many points depending on what kind of game or project you're building. So this is, I'm going to leave it at 5,000 because that's actually going to be dense enough for the grass type that I'm going to be using, but that's where you actually define the number of points in each little grid zone. Okay, let's go ahead and add our own static meshes here to the static mesh spawner. I'm going to go ahead and click on it, and I'm actually going to remove 2 grass meshes here by clicking the remove all elements button so that we can go ahead and add our own. So I'll add plus button here to add a new mesh entry, and I'm going to go ahead and add a grass mesh here. Now I did want to mention that this landscape material and also the grass meshes that I'm using, as well as this PCG runtime grass setup, I've already built into the Aziel Arts landscape material, and I give that away for free. It's a great state-of-the-art landscape material that incorporates basically everything you would want: paintable landscape layers, auto material layers, the old runtime grass system if you'd like to use that, or this new PCG runtime grass system. It's already set up for you, ready to use. It also incorporates nice displacement, texture breakup to fix tiling textures. It has just a lot of great features, and if you'd like to grab that material, you can head to the link in the description and enter your email, and then it'll go ahead and send you a link to the page to download that material. Enjoy. All right, so I'm gonna jump back in here and I'm gonna get the grass that comes with that landscape material. So again, you can always grab this if you'd like to follow along. So I'm gonna come over here to the folder, and we're gonna come to the landscape grass foliage, assets, and meshes, and this is where my little grass meshes are. So I'm going to add these grass meshes to my PCG graph here. So I'll add the first one, which is my clump 4. Just as sort of a side note, I have noticed that when you wanting to spread very dense grass over a landscape area, it can be more efficient and give you denser grass with fewer calculations by just getting a kind of nice little clump here of grass that tends to spread more densely across a landscape better than like individual blades or very small clumps. So in this case, I'm going to use a big clump, and then I'm going to use a few little smaller clumps to kind of break it up. Kind of like most of the spawning will happen from these larger clumps. Okay, so I'll add that static mesh in there, and I will go ahead and add a new one, and this one will be grass clump 1 in the descriptor. So there's just a different, slightly taller grass clump, and then the third one will actually be my blades tall one here, which will kind of just help kind of be a little bit taller and break up the kind of the look of the grass meshes. Next, I want to go ahead and add the optimizations in here to the static mesh spawning. Even though we're spawning, pretty efficient meshes, we still need to adjust some of the settings here in the static mesh spawner, especially for grass. There's a bunch of stuff happening that we really don't need. And then we want to kind of double check that we're adding these optimizations every time we add static meshes here, especially if we're spawning a ton of them. Here are some tips for optimization things you can add in. So first thing, I'll come over here to this here. And what I want to do is turn the shadow cache invalidation behavior from auto. I want to switch that to static. What this is going to do is basically say, I don't want to invalidate the shadow cache by just wiggling in the wind, because they have some world position offset pivot painter based wind that's happening on the grass. And so I'm saying I don't want to recalculate the shadows just because they're wiggling a little bit in the wind. So that really helps a lot with foliage like grass. And I want to actually do this to all of the meshes, so not just the first one. So the easy way to do that is actually just search the thing we want to change here. So if I search shadow cache, we can see these are all the different shadow cache invalidation behavior options for each of the meshes. So I can just switch them all to static. I might also turn off distance field, and I might turn off affect distance field lighting. I might also type in WPO, world position offset, and I kind of want to disable their grass wind at a certain distance. I don't need them, wiggling in the wind far away. That's going to be just needlessly complicated for the scene. So I might just keep their wind distance to something like 3000. Again, this is something you have to test in your own projects. But this is basically say at a 3000 distance, stop actually blowing in the wind. And that actually looks like too close to me. Some of these grasses here, I feel like should be moving. So I'll up that to maybe 5000. And if you really want to make this super efficient and even easier on your frame rate, you could also actually disable shadows, cast shadows. I'm going to leave them on, but that's just an option available to you. Okay, so we've added our meshes here, and we're spawning them, which looks great. So now let's come over to our runtime grass PCG parameters and adjust some of the settings. So I'm going to actually increase the scale here because these are way too tiny. So I'm going to adjust the points minimum scale to something like 0.5 or maybe 0.8, and the points max to 1.5. So we'll just do 1 to 1.5, maybe something like that. And here under the scale by density min and max. Now here's what's basically taking the noise, mapping those into density values, which is a 0 to 1 value, and then basically adjusting the scale up and down of the grass. And this helps the grass have a kind of a scale variation based on the noise pattern that's inputting to it. But in these preset settings, for some reason it's clamping the grass scale way down to basically 0.05 to 0.3. So that's too small and making my grass way too small. So I'm going to up this basically as the max is let's say 1.5 and the minimum is 0.5. There we go. So now our grass is a little bit bigger, covering our landscape a little bit better. If I wanted to get this even denser, you can see these little bald spots here, little breaks in the grass. That's coming from the noise pattern, like I mentioned. So we could go ahead and come to the spatial noise strength and maybe up it to 0.6. Oh, that increases the strength. Maybe we'll drop it to 0.3. So that's just lowering the strength of that noise. This will create a lot more healthy looking grass. If you want sparser grass, you could adjust that accordingly. So this is looking great. Now we can see that the grass is spawning here in little chunks in the distance. So how do we actually control the distance that the grass spawns? Obviously, this will be also dependent on your project, how close you want. For example, in this grassland here, we see pretty far in the distance, right? It's like we can see this kind of these rolling hills. And so the grass kind of has to go pretty far. But if you were in like a forest, you could have this cut really close, and you could have really dense like ferns and like leaves on the ground, really dense spawning foliage, and cut it kind of close to you, like, you know, like maybe this or even closer, because of the trees, because of the way the landscape is, you don't actually see that far into the forest. So you could really be sneaky here and get a ton of really dense foliage directly around you, but then just not spawn it when you get to a certain distance. So this is really something you have to play with depending on the kind of foliage that you're using and whatnot. But how would we actually control that? So if we double click on this PCG graph to open it again, the way these runtime grass spawning is happening is using, like I mentioned, these grid sizes. And you can see here, if we click on the graph settings, we're basically saying for this general graph, this whole graph, we want the hierarchical generation default grid size to be unbounded. We're saying no grid sizes for this whole graph. Get the landscape from everything. Depending, like if we're far away from the landscape, but the PCG graph still overlaps with it, still get it. Don't worry about it. But then we're very quickly here clamping it down to a grid size of 1600, and that's basically what's defining size of these little chunks that are loading in. And this grid size node we could change to be 800 here, which would, you can see, make much smaller grids, or 3200, which would make, you know, bigger grids. But 1600 is kind of a nice middle ground that's pretty efficient, because if we have too many small chunks of data, that can be heavy. If we have too big chunks of data, that can also be heavy. So this is kind of like a little kind of nice middle ground, is 1600. Now that's the size of those chunks, but the distance that those chunks for each size group is located in the graph settings. So if we click on the graph settings, we scroll down to where it says runtime generation and generation radii, we can scroll down here. And we can see for each generation radii, 1600, for example, it's spawning at a distance of 3200. And for 3200 grid size, it's spawning at a distance of 6400. So you can see it's kind of defining for each kind of grid size section of your graph how far those things are calculated. If we lowered the 1600 grid size down to like 1000 or maybe like 2000, bam, it's just inching it closer to us. We're not loading as far. If we load it at 1000 difference, you can see that it's really just loading pretty close to us. So this is how we define the distance that the meshes are loaded. So if we wanted to get a little bit further, we could load it at 4000. That would be a little bit further away. So that is how we define the distance. Now, you'll have noticed, those of you who have set up similar systems like this, or have played games or systems that have runtime foliage spawning, this is kind of an obvious visual of these chunks loading in. And so there's a few different things we can do to make that loading in be less obtrusive. The easiest low-hanging fruit way you can do this is just literally to, in a spherical zone around you, stop loading the instanced meshes. So you're still loading in chunks of data, but you're not actually showing those meshes or rendering them until they get to a certain distance, which will create a much more natural kind of rounded kind of arc around you for spawning. So if we come back to our grass PCG graph, this is done in the static mesh spawner. So if we type in cull distance, we can see the instance and cull distance. So if we remember our graph settings here, we're loading at a distance of 4000 here. If we come to our static mesh spawner and we put our end cull distance here at 2500 for all of our meshes, you can see it creates this nice spherical loading of the grass for us. Now, this is the basic way to do it, and you could do this actually, if you did this a little further in the distance, it would, you know, have this nice kind of like a little less obvious loading to it. It's also very fast, very efficient, but there are other visual ways to blend the grass. I cover 2 different ways for how to do this in my PCG course, which you can find along with all of my other environment art courses as part of ASIAL Art Academy. You can find a link to that in the description. So I cover how to set up both fading of assets through transparency, dithered transparency using masked objects, or I cover how to do actually world position offset based scaling. So the objects just little scale down into little nothing dots and then disappear as you get farther into the distance. So those are different, like more gradual ways to spawn things in and out. I've actually built the transparency version of the fading into this grass material that comes with the ASIAL Arts landscape material, which, like I mentioned, you can download in the description. So I know that can be adjusted for those objects. automatically. So if I go ahead and I if I open up that material for that grass, there's a distance culling option in the material instance. And this is controlling, at basically between 3000 and 6000, I'm going to fade these foliages out using a masked dithered fading. So it's a pretty efficient mask-based fading method. So I'll actually just increase the loading distance far enough for that to start happening for these graphs so you can see what that looks like. So if we come over here to our graph settings again, we scroll down to generation radii, and if we boost this radius to spawn at a distance of 9000, then I also have to turn off the cull distance for my meshes here. Cull distance, and maybe we'll just up it to 9000 as well, or you could turn it off completely, either one. And now you can see there's like a gradual transparency fade of the grass into the distance, so it's a lot more kind of aesthetic. So you can go ahead and download that material and reuse the material logic if you'd like, or like I said, you can find the course for how to set that up for your own materials in the description. So great, so we have our grass spawning efficiently. It is fading off into the distance. Our only issue here is that it's spawning everywhere. So on our rock areas here that the auto material is creating, if we have also some painted landscape material areas where there's some kind of gravel and things, and the grass is just spawning everywhere. So we need a way of controlling where this grass is spawning. In this tutorial, we're going to cover how to control this runtime grass from the landscape grass outputs from our materials, our landscape materials. But of course, you could also use slope in your PCG graph, or look for the underlying landscape material, things like that, and do that in your PCG graph as well. So we're going to cover how to take the data from our landscape material as we would with older versions of landscape grass. So in my landscape material here, I have this set up already, but I just want to show you really quickly what it looks like in case you are less familiar, or you have your own landscape materials. Basically, you use this node, landscape grass output. And in the landscape grass output, you make a new landscape grass type. And now we need to make a landscape grass type asset to put in here. I'm going to go ahead and come here and right click and just make a landscape grass type. I'll call this LGT runtime grass. And this is very important what we name this asset, because we're going to be looking for it on the PCG graph when it samples the landscape. So we make that new landscape grass type asset. And normally if we were using the traditional landscape grass method, we would come in here and we'd start adding some additional grass meshes here, and it would pick up on those and start spawning them. But in this case, we just need literally an empty asset, which is going to be used to pass the data from the grass material, or the landscape material rather, to the PCG grass. So we have this empty landscape grass asset. I've made the new input here in the landscape grass. So I'll just come over here and drag that in, and I'll give it a name, and we'll call it PCG grass. And what we plug in here is really up to you and how you have your materials set up. You could plug in just a landscape layer sample. It's basically just a black and white mask for where this landscape grass should show up. You could use a slope, auto material output, mask, whatever it is. What I have here is a landscape layer sample for my landscape paint layer, and I'm just subtracting my auto material rock mask, black and white mask from that, and that's how I'm getting where the grass should be. So you could do this all kinds of different ways. So I'm going to plug that directly up to my PCG graph here. And like I said, if you download the landscape material, this is set up already for you. And probably when you update your landscape material, your grass will disappear, which, don't freak out. All we have to do is come back to our PCG graph and hit force regenerate, which would go ahead and generate our grass again. Okay, so how do we add that filter basically from the landscape grass type? We can see here, if we expand here, we can see here we're getting our landscape data, and that's coming into our point generator. But if we click on the point generator and hit A to look at the point data we're getting in, and we click on any of these these little partition chunks coming in, you can see there's no actual information about the landscape grass type here, or landscape layers, or anything. That's because of the way that the point generator is generating the points. It's getting the bounds for the landscape, and it's creating a grid of points and then it's projecting that or moving those points down to the Z position of each area of the landscape. So it's not actually sampling the landscape. That would be done on the CPU is my understanding. So we have to use a different node to actually get that landscape grass type information. If I come over here and drag off of this landscape grid size, we type in grass here, we can use generate grass maps. So this is coming from the landscape data in the change grid size node output, and it's giving us this grass map output information. So actually, I'm gonna move it down here. All we need to do is find a way to plug this into our existing point generator here. Now, this is the part that gets a little tricky, because in order to adjust this node here, if we come to settings and then we open our HLSL editor here, this is actually where all the information in the node is basically everything that's happening in here is defined through this code, which can be pretty daunting to those of us like me who are not HLSL coders by trade. What I'm going to do is just give you a easy code snippet that you can just copy into this node here, which will basically do the filtering for this data here and filter out these points based on the generate grass maps. Before we paste that code in here is just add a new input here to the point generator to pick up on that data. And so we'll go ahead and hit the plus button, and here under input pins, then we'll expand that input pin and we'll call it grass maps. And this is very important that you name this exact thing, grass maps, plural, no spaces, capital G, capital M, because this is the name of the variable that's going to be picked up here in this code. So the snippet I'm giving you is looking for this grass maps variable, so you need to name it this exact thing. And the allowed types here, we're going to switch it to base texture, which is the same data type here as the grass map coming in. So now we'll plug that in. Okay, so we have our data going into our point generator. Now we need to actually pick up our data here inside the code and do something with it. So you can see here, if you're curious, you can look and look under these different comment sections here. We have the generate random offsets, generate the X and Y positions, the random rotation, random scale. It's really cool. It's basically defining all this GPU calculation basically through this code. But we want to come down here all the way right before it says write outputs. So I want to do all this calculation it's doing, then do our little filtering from the grass maps, and then continue with its normal output. So what I want you to do is go ahead to the description of this video. I have written the code snippet that you need to paste into this section here, but we're going to go ahead and copy that little code snippet in here, which is basically a comment saying grass filter, and then we are getting the position of the landscape input. We're setting our density based on that. We're using the grass map input. We're basically comparing them and using a threshold here to remove points that are outside of that. You can see here it says there's an if statement here that says if the density is greater than the threshold, which is coming from here where we define our threshold, grass map sample world position, and this is important here. So remember what I told you, you need to remember what your landscape grass asset is called from our landscape material. Remember, that's the asset that we put here in our landscape grass output, which in our case we called LGT underscore runtime grass. That is the name you need to go ahead and put in here where it says PCG grass. That's very important. Otherwise, it's not going to look for that grass map from the information that you're providing it. We'll go ahead and we'll type in LGT for landscape grass type underscore runtime grass, and I'm going to triple check that that is named correctly. Go ahead and hit save for our graph. Last step here is we need to come to our grass maps node and tell it to look for that particular grass type in the input grass types, because we could have a ton of different input grass types, and we just want to make sure we look for those specific ones. So here we need to, under the selected grass types here, hit the plus button and look for that grass type in the incoming data. So we'll put that exact same name we just put in the code, LGT underscore runtime grass, hit enter. And here, this is important, under the exclude selected grass type, we want to instead uncheck that so it's keeping the selected grass type. It's a little confusing, feels backwards, but that's what we want to do here. Now we're going to go ahead and hit save again. Okay, and then what I like to do is hold down Control and click this force regeneration button just to kind of clear the whole cache of the PCG graph and just respawn everything. And if we don't get any errors, we should see our grass now spawning in the correct areas of our landscape. Now, I just want to mention there's a few areas that this can go wrong. So if you're getting an error here, it could be from these three main causes. Number one, there's a mismatch in your naming. For example, this landscape grass type does not match the code here where it's saying grass map sample world position. This is not matching this name, and your grass map, your generate grass maps node doesn't also have the same name, and you don't have this unchecked, which means otherwise it's excluding that. So make sure this is unchecked. Make sure all three of those locations have the same name. That's number one. Number two, if all of those are correct, you want to check that your input here on the point generator that you made is grass maps here without a space, plural, that the allowed type is base texture. If both of those are correct here, then the only problem that you must have is that somehow your landscape material is not correctly passing the grass map information out of the landscape. It's looking for, it'll say probably, like, most likely the error will say grass map type is not found, or something like that. And in that case, you need to open up your landscape material. I would just plug a 1 into the output just to put it everywhere, just to make sure you're getting it correctly. And then you can kind of troubleshoot from there inside your landscape material if you're actually getting the correct information out. I've run into all three of those issues while setting up this tutorial, so I just wanted to mention that. If you do have an error in your graph here, it's probably one of those three problems. All right, so we have our grass looking pretty good. The last step here is to go ahead and test this at runtime. And I can tell you already that we're going to run into a slight issue, but let me show you really quickly first what happens here. So I'm going to go ahead and test this with a third-person character blueprint. If you don't know how to add the third-person character blueprint to your level, really quickly you come to the add button and come to the add feature or content pack, and you can add your third-person character. And then we can come to the world settings and choose third-person game mode here as one of the options. When we do that and we hit play, we'll go ahead and play with our third-person character. So let's go ahead and test that this grass is actually working at runtime with the character. So go ahead and hit the play button, and we have an issue here. It looks like the grass is not spawning correctly. It is in our viewport in the editor mode, but as soon as we hit runtime, even though it is spawning at runtime, ostensibly, it's not getting the grass map information from the landscape at runtime. And this is something that actually does need to be enabled using a console command, unfortunately. So in order to do that, we're going to go ahead and type in grass map dot always build runtime generation resources rather. And I will go ahead and put this in the description as well if you want to grab it. But we want to set this to 1. It is 0 by default, which basically means, as it describes here, it's not looking at the landscape to get the information from it for the landscape grass maps. Even in PCG, even though PCG is looking for it, it's suddenly not getting it during runtime, and so therefore our grass is failing to spawn. And actually, before we do this, if I go ahead and hit play, you can see if we open up our output log here, we scroll down to the bottom, all the way at the bottom, we can see here this error is saying runtime partition actor. So one of the PCG partition actors here in the data table, it's looking for LGT runtime grass, which is what we called our runtime grass type and what we're looking for in the code, in the HLSL code a minute ago. So we're looking for that, but we're not finding it. It's not present in the tags in incoming data. So you can imagine that this key command, this console command here is basically saying always build the runtime generation resources. So always, continue to get this type of data from the landscape even during runtime. So if we go ahead and it's 0 by default, but if we set it to 1, then if we go ahead and hit play again, now our grass will successfully spawn at runtime. Yeah, this is just something you have to either set on begin play, or especially if you're building this in a game, you also probably need to add this console command into your engine build file. But we can see now our grass is beautifully spawning in the distance at runtime. All right, there you go. That's how to set up runtime PCG grass, spawning on the GPU and sampling your existing landscape materials for the grass type where it should be spawned. Hopefully you found this helpful. If you did, let me know with a thumbs up or a comment if you have any questions or would like to request other types of runtime spawning, how to approach that. Like I mentioned, you can find more of my training on PCG in Aziel Arts Academy, which I will link below, as well as all my other courses on environment art. I will see you in the next one.